this video, I'm going to describe the supporting ongoing changes in thinking practice in the context of the It's All Connected data puzzle. So the goal of this practice is to help students test their current understandings, their initial predictions for the investigative question against an authentic data set. Key to this practice before students are asked to go and analyze and interpret the graph is to talk about the graph, talk about the data sets as a whole class. This is especially critical in this data set where we have a lot going on, and we'll look through that data set here shortly. After talking about the graphs, then students should go out and work individually or in pairs to analyze the data set, identify and explain patterns. If you already have a data analysis strategy that works for your students, feel free to lean on that. We've had a number of teachers use the WIS-WIM strategy, what I see, what it means, where you're kind of annotating the graph, identifying patterns you see and what they might mean on the graph. But we'll leave that up to you. For this practice here, again, students have made predictions about the investigative questions, and now it's time to look at some data collected from Gina's Data Talk 2 drone to test the predictions. And so here is that data set on the right here. We have on the x-axis absolute humidity, and so below here you can see to the left, this is less moisture in the atmosphere. To the right, this is more moisture in the atmosphere. And on the y-axis, we have altitude in meters. So the drone is measuring the moisture upwind, over, and downwind of a lead, a crack in ice, up in a vertical space, up in altitude. Up here, we can see the dashed black line represents moisture upwind of the lead, the dashed blue line over the lead, and the red line downwind of the lead. And so with your students, as you're helping them make sense of this data set through discussion, questions like, what does the x-axis represent? Which direction would be less moisture in the atmosphere? Which would be more? What does the y-axis represent? What do the different lines represent? And then maybe identifying a point or two and having students describe what's going on at a certain elevation or certain altitude. That could be an effective way to help students familiarize themselves with this data set. Once students have had an opportunity to discuss the graph as a whole class, then they go out individually or in groups and identify and explain patterns they might see to test their prediction, what effect, if any, for the investigative question, what effect, if any, do leads have on the transfer of moisture between the Arctic Ocean and the atmosphere. I'm going to cut now to the student worksheet. Here we have, again, the supporting ongoing changes in thinking practice. Here's that graph that we were just looking at on the slides. And we can see, again, blue is over the lead, red is downwind of the lead. So we're looking at humidity. It seems at these lower altitudes, over, again, blue and downwind in red, slightly more humid in those locations than upwind of the lead, as we might expect. And that pattern persists to almost an elevation of an altitude of 80 meters. After that, it seems like, yeah, downwind of lead has higher humidity, but they're more or less the same after an altitude of 80. So upwind or downwind and over the lead, humidity seem to be a bit higher up to a certain altitude, at which point the pattern seems to cease to exist. To help students identify and explain patterns they see in this data set, we point out specific altitudes and ask students to describe downwind and upwind humidities of the lead. And then again at 140 meters. And so what they'll discover is that there were higher humidities downwind than upwind at lower altitudes. But at higher altitudes, that pattern is not as pronounced. We'll have students describe that pattern and create a rule, and then revisit their prediction to see if the data supported their prediction for the investigative question. At this point, we're ready to move to the final practice, where students will be asked to construct an evidence-based explanation.